Take a barrel of raw crude from the Orinoco Belt in eastern Venezuela and tip it over. Nothing happens. It doesn't pour. It doesn't splash. It sits there, black and motionless, closer to roofing tar than to anything you'd recognize as oil. Some of it is denser than water. Drop a spoonful into a glass and it sinks. This is the substance that makes Venezuela, on paper, the richest oil nation on earth. More proven reserves than Saudi Arabia, more than Iran, more than Iraq, Kuwait, and the United Arab Emirates put together. Venezuela produces about 1/8 as much oil per day as Saudi Arabia does. Everyone assumes they know why. Sanctions, politics, mismanagement, all of that is real. All of it is documented. None of it explains the barrel that won't pour. That has a different cause, and the cause was alive. OPEC's most recent statistical bulletin puts Venezuela's proven reserves at roughly 303 billion barrels. Saudi Arabia holds about 267 billion. Venezuela leads the world, and it isn't close. Now here's a second number from the energy analytics firm Rystad. 29 billion barrels. That is Rystad's estimate of how much Venezuelan oil is economically recoverable, roughly 1/10 of the official figure. Researchers at Rice University's Baker Institute have put it nearer 100 billion. Same country, same rock, same oil. Estimates that disagree by a factor of 10. Nobody here is lying. The oil is unquestionably present, more than 1 trillion barrels of it. The argument isn't about geology at all. It's about what happened to that oil after it formed. And once you understand that, you can't read an oil reserve figure the same way again. Not Venezuela's, not anyone's. The Orinoco Belt runs about 600 kilometers east to west along the north bank of the Orinoco River and roughly 70 kilometers north to south. Call it 55,000 square kilometers, larger than Denmark. Beneath it, in soft, unconsolidated Miocene sands of the Oficina Formation, sits an accumulation of oil that the U.S. Geological Survey describes as more than 1 trillion barrels in place. Estimates for the belt range from 900 billion to 1.4 trillion. That is roughly equal to all the conventional oil the world has ever had. In 2009, the USGS ran a formal assessment and put the mean technically recoverable volume at 513 billion barrels, within a range of 380 to 652 billion. Read that adverb carefully. Technically. The USGS made no attempt to determine how much of it was economically recoverable. It answered the engineering question, and then it stopped. That gap between what can be lifted and what is worth lifting is the whole subject of this video. The reservoir is shallow, mostly 800 to 1,500 meters down. Porosity above 20%. Permeability any petroleum engineer would call excellent. By every structural measure, this should be among the easiest oil accumulations on Earth to produce. It is not. And the reason it isn't is the reason it's shallow. The oil in the Orinoco Belt did not form where it now sits. It was generated far to the west, in deep source rocks near the Andean foothills, cooked under heat and pressure the way good crude is supposed to be. When it formed, it was light, mobile, sweet, the kind of crude that rises out of a well under its own pressure. Then it began to move. Oil is buoyant. Water fills the pore space in rock, and oil, being lighter, migrates upward and sideways along whatever permeable pathway it finds. Across millions of years, this oil traveled hundreds of kilometers east, through porous sandstone, into the vast shallow sand sheet of the eastern Venezuela basin. There it stopped, trapped beneath a seal, sitting barely a kilometer below the surface. As geology, that migration is a triumph, an enormous volume of hydrocarbon gathered out of the deep earth and concentrated into one accessible place, shallow enough to reach with a modest drilling rig. For the oil itself, it was a fatal mistake. Deep reservoirs are hot, rock temperature rises with depth, and past roughly 80 degrees Celsius, nothing lives. The heat sterilizes the reservoir. Oil sitting in a hot, deep trap stays exactly as it was made, indefinitely. Below 80 degrees Celsius, which in practice means shallower than about 1.5 to 2 kilometers, the rock is cool enough for life. And wherever there is porous rock and formation water and hydrocarbons and a temperature under that threshold, microorganisms arrive. They eat the oil, not evenly. They eat it selectively. Microbes preferentially consume the light, short-chain molecules, the N-alkanes, the fractions that would have become gasoline and diesel, the small mobile compounds that let a crude oil flow at all. What they struggle to digest are the large, tangled, ring-heavy molecules, the asphaltenes, the resins, the compounds carrying the sulfur and the metals. So across geological time, in a reservoir sitting at a survivable temperature, an ocean of light crude was slowly eaten down to its residue. Petroleum geologists have a clinical word for this: biodegradation. And the Orinoco Belt is the largest example of it anywhere on Earth. Field surveys of the belt found the crude in the Zuwada area almost totally degraded. In the Hamaka area, roughly 90% of the crude is totally degraded. The bacteria did not leave much behind. That is the hidden truth about the Venezuelan oil field. Sanctions did not make this oil heavy. No government made it heavy, long before any of them. In warm sand beneath what is now Venezuelan savanna, something microscopic found an ocean of light crude and ate the best of it. Look at the residue. API gravity is the industry's density scale, calibrated so that fresh water sits at exactly 10 degrees. West Texas Intermediate comes in around 40. Saudi Arabian Light around 33. Raw Orinoco crude typically measures below 10 degrees API. Some samples run as low as 4. It is denser than water. Its viscosity in the reservoir runs into the thousands of centipoise, thick enough that it will not travel toward a well bore unaided. It carries 3.5 to 5.5% sulfur, which makes it aggressively sour. It carries vanadium at 600 to 1100 parts per million, a metal that poisons refinery catalysts. Asphaltene content runs into double digits by weight. There's a strange footnote here. Orinoco crude is actually somewhat less viscous than the bitumen in Canada's Athabasca oil sands. In that one narrow respect, Venezuela got the better deal. But Athabasca bitumen sits close enough to the surface that much of it can be strip-mined with shovels. The Orinoco sits a kilometer down, too deep to mine, too thick to flow. It got the worst of both worlds. Everything downstream of that is arithmetic. Because the oil won't flow freely, the recovery factor is brutal. Under primary cold production, pumping without steam, operators in the Venezuelan oil sands recover something like 8 to 12% of the oil in place. 9 barrels stay underground for every one that surfaces. Because the oil is too thick for a pipeline, it must be blended with a diluent. The USGS puts the requirement at roughly 1 barrel of diluent for every 3 or 4 barrels of extra heavy oil produced. Venezuela has spent years importing naphtha in order to export its own crude. The country's flagship export blend, Pre-16, is precisely that: extra heavy crude of 7 to 10 degrees API, cut with lighter material until it reaches about 16. Because the crude is sour and metal-rich, it then has to be chemically upgraded, cracked into a lighter synthetic crude before a conventional refinery will accept it. Upgraders are multi-billion-dollar industrial plants requiring continuous capital and expertise. And heavy oil reservoirs are unforgiving. Wells shut in abruptly can suffer permanent damage to their production potential. This is not a shale well in the Permian that you switch off and restart. The reservoir does not forgive. Add it up. Every step costs money, which means every barrel in the Orinoco has a price below which it is worth precisely nothing, which brings us back to 303 billion barrels. In 2005, Venezuela launched the Magna Reserva project, an effort to quantify and certify the Orinoco's oil. Over the following years, PDVSA certified around 256 billion barrels of the belt as recoverable. In July 2010, on the strength of that certification, Venezuela overtook Saudi Arabia as the country holding the largest declared oil reserves in the world. Between 2005 and 2011, Venezuela's reported reserves nearly quadrupled, from under 80 billion barrels to nearly 300 billion. No discovery drove this. Nobody drilled into an unexpected ocean of crude. Geologists had known about the Orinoco since systematic exploration began in the 1930s, when the earliest wells came back with 7-degree API crude, too thick to produce. What changed was a classification. Barrels moved from the resource column into the proven reserve column. And proven reserve is not a geological term. It is an economic one. It means, at current prices, with current technology, this can be brought to the surface at a profit. Oil in that period was climbing toward $100 a barrel. At $100, a great deal of Orinoco tar pencils out. When prices collapsed in 2014, and again in 2020, much of that oil arguably stopped qualifying. It was never reclassified back. That is why Rystad says 29 billion and OPEC says 303. Both describe the same rock. They assume different prices. And here's what changes everything. The reserve is a function of the oil price, not a measurement of the ground, a bet on the market. Push crude high enough and hundreds of billions of barrels of Venezuelan tar quietly become proven. Let it fall, and they quietly stop being oil at all, without one molecule moving. The same logic governs Canadian bitumen, American shale, and every reserve figure any nation has ever published. Venezuela is simply the most extreme case on Earth, the place where the gap between what exists and what counts is widest. Which means the world's largest oil reserve is not really a place. It's a threshold. It expands and contracts with something happening on a trading floor thousands of kilometers away. And the rock beneath the savanna never registers the difference. It has never once moved. The subsurface, as one Bernstein analysis put it, was never the problem. So the number stays where it is. 303 billion barrels, largest on the planet. It will still be the largest next year. What the number never told you is that a reserve is not a bank balance. It's a wager, a claim that at some price, with some technology, this material can be lifted at a profit. Change the assumptions, and the greatest oil reserve in the world becomes a line item, without a single barrel moving. If you found this video interesting, don't forget to like and subscribe. Leave a comment with what topic you would like to see in a next video. Thanks for watching.